Now we're going to talk about normal stimulus and response for HTTP, and hopefully through some of the examples we've already gone through and digging in on requests and responses, you've already got a pretty good sense of what that looks like. Now, we dug into requests and responses to some degree separately, but you can definitely see how they're related. So we'll talk about a couple normal SNR concepts, both in theory, and then I'll show you some packets just so you can see the actual direct relationship between a specific request and response. Now, we'll start off with probably the most common, definitely the most common by far HTTP transaction that you'll see, and that's an HTTP GET. Of course, the GET request method is one we've talked about. It's one we're going to be using from the client to retrieve things from the HTTP server. So that's what you're using to download HTML web pages, what you're using to download images, scripts, all those different things happen with a GET request. Now, with a GET request, we have here a web client and a web server. And the client, once a TCP session is established, that's important. HTTP runs over TCP, but once that session is established, we issue a GET request to the server. And this on the arrow on the screen here represents the start line for that GET request. So we see the HTTP method, the URI, in this case it's /index.html, and the HTTP version, which in this case is 1.1. The web server will receive that information and it will send the data back along with an HTTP response code. In this case, you see that here. It's a 200 OK, which would signify that the data was delivered successfully. Now, of course, we know that most web pages or many web pages aren't going to fit back in a single packet. We've only got around 1,500 bytes we can use there. So most of them are going to take multiple packets. So I'll show you in Wireshark here in just a second that not every response packet is going to have this HTTP 200 OK. You're actually going to have to look for that in Wireshark in the last packet. We'll see that here in practice. But again, transactional protocol, very simple. GET request from the client for a resource and then a response back from the server. Hopefully a 200 OK that stating that the data was there and was transferred. Maybe it's not. Maybe you get a 404 not found. Maybe you're trying to access a resource that you don't have permission and you're getting a 403 forbidden. A couple different options here, but hopefully in an ideal state, this is what the normal HTTP GET looks like. I've opened up http google.pcapng, and this is a really simple example of an HTTP transaction with a very simple GET request and an OK response. So let's actually step through this, and we'll start here in the packet list window. Notice we have a source and destination IP address, so we've already had some type of DNS resolution occur that's going to allow us to get the IP address for the domain we're communicating with. And in this case, as the name implies, we're communicating to Google, google.com. So in this case, our source IP address is 172.16.16.128. That's our internal address. Our internet-facing address, the one belonging to Google, is 74.125.95.104. So we know what IP addresses we're dealing with. In order to communicate over HTTP, we have to establish a TCP session first, and that's what we have going on in the first three packets here. You see that over here. We see SYN, SYNAC, ACK, our normal TCP setup process. So we have that going on, and then HTTP-based communication can begin. Of course, notice as well that that's over port 80, which Wireshark is identifying as HTTP for us based on the fact that it's on that port, 80 being the traditional port that is associated with HTTP communication. Now, let's go ahead and look at this GET request because that's really the first HTTP thing we see. I've already got the HTTP header expanded here, and we see a lot of the information we saw earlier when we examined HTTP request in detail. We start with the start line. In this case, we're getting slash. Now, slash, you look at that, and if you've not seen that before, you say, okay, well, what does that mean? That's not actually a file, and most of the things we've seen thus far are retrieving files. Well, slash basically means to get the root of the shared web server directory. On the web server side, you're essentially choosing a folder and saying everything in this folder is what's being shared out over the web server, right? You're not sharing out the entire server. That would not be very secure, not be a very good idea. You're sharing out a specific folder, and that folder is your web root or your document root, and that's what you're sharing out to the world. So when you say get slash, you're just saying to retrieve whatever is at that document root. Now, the server will also be configured to point people when they request that just slash to a specific document. So normally that's going to be an index.html, an index.htm, index.php, some type of index file is generally what that's going to be pointed to by default in most cases. So in this case, we're getting slash. So we're just saying get the root of the home directory. We see our host here is www.google.com, which is probably what was typed in the URL bar in the user's browser. And we see a couple of other interesting pieces of information. It looks like this request was made using Firefox on Windows based upon this user agent. We see Windows mentioned here, Windows NT 6.1, I believe that, and then we have Firefox 357 as well. That's quite a bit of an older version of Firefox. This is an older packet capture, but we see what we have going on. We have some accept statements, so we know what the browser will accept. It looks like we're looking at English language here. We'll accept gzip encoded content, specific character sets, and so on. It looks like there's already a cookie associated with this connection, one that's already been set from visiting Google before, perhaps. But that's pretty much it. That's pretty much our transaction, our Google, our GET request. Of course, there's no message body here. We end with this new line because, generally speaking, a request isn't going to have a message body associated with it. So that's our request, and then we can go ahead and look at the response. Now, if you haven't looked at HTTP data before, after you see the request, you might immediately expect to see the response. But remember, most of the time the response is going to be bigger than something that can be sent in one single packet, right? It's going to be bigger than 1,500 bytes. So that's going to have to be done over several packets. And we're also using TCP, which means we're using this session-aware protocol that's really concerned with reliability. So we have some additional overhead associated with that in terms of control packets. So once we send our GET here in packet 4, notice we actually just get a TCP ACK packet back, right? All the packets have to be acknowledged in a TCP-based communication sequence. So that's what we have going on here. So we have our GET in packet 4 and acknowledgement in packet 5. And then starting in packet 6 is when data starts being transferred. And you can tell the difference. If we look at packet 5, you see the packet bytes. Not a lot's going on here. That's because it's just a TCP control packet with no additional data after the TCP header. However, starting with packet 6, we have data here. And in this case, you actually look and you see, if you look down here, you'll see HTTP 1.1 200 OK. Well, that's interesting. That's actually our response, right? That's what we would expect to see. But if we look up here in the info column, it says TCP segment of a reassembled PDU. Well, what's it telling us there? Well, in this case, the way Wireshark chooses to interpret this data is to actually save the application layer data for the end of the stream. So if you look down here at the bottom at packet 12, you see that HTTP 1.1 200 OK. So that's actually occurring way up here. That's occurring in packet 6. Like that's the first thing that the server responds with before sending the data. Remember, the data structure is the start line, and then the response headers, and then the blank line, and our message body. So our message body is actually last, and our start line's first. But the way Wireshark chooses to show you that, if you want to dig into it, is such that all of these packets here, so between packet 6 and 11, those are all TCP data packets. So we see those packets. Here's a couple of them here. Here's an acknowledgement. Here's a couple more. Here's another acknowledgement. And then the final packet is actually going to show you the completed reassembled HTTP header. And reassembled is the key word there, because what Wireshark is doing is it needs all those other packets to reassemble the HTTP header and dissect it properly. So it has to do that. It has to wait to the end to show you all the information. So that's the key thing to keep in mind, is that if you're looking at the packet list window or packet details window, the request, the response to the request will not actually be visible, easily dissected at least, until you get to the end of the stream. Now, there are a couple ways to shortcut yourself to that. One is you can actually just right-click in here. Let's go ahead and follow. In this case, we'll follow the HTTP stream, and that'll give us the whole stream, right? We can go ahead and look at all of the HTML content delivered. But the important thing is if I exit out of this, notice in the back that we've highlighted this particular TCP stream. It's only TCP stream equals 0 in this one, because that's the only one in this capture file. But that's narrowed it down, and that way we know at the very bottom of this particular stream, we should see HTTP 200 OK. So we've got the stream we want to see in this case, and then we can examine the response. So that's important to know. That trips a lot of people up. They're like, why can't I see the response? It should be right after the request. And it actually is all the way at the end. You have to look past all these TCP data packets that are actually being transmitted to get to the final one that shows you what you're ultimately looking for. So with that said, let's go ahead and actually look at this response packet to our original request. And again, this is encompassing the reassembly of all of these other packets. Now in this case, we have the HTTP header expanded. Notice right above that, it tells us that it's actually reassembled all these TCP segments. It tells us the amount of bytes in each one of them. So it looks like 1406, 1406, 1406, 102, and 537. And it actually tells us the segment numbers. So 6, 7, 9, 10, and 12. We skipped a couple numbers there. Remember, there's TCP acknowledgements going on, so that's where the gap is. Now, as far as the HTTP header here, we have our start line. We see we got an HTTP 200 OK. That means our data is being returned and processed successfully. We have a couple different caching things related here. We have expires, the date, which can be used for that, cache control, and so on. We have content type fields, which tell us about the content being delivered. In this case, it tells us it's HTML, so just a simple HTML file. That it's gzip encoded in this case for better efficiency, so it's encoded and compressed in this way. The server in this case is GWS, which is a custom Google web service. We have our content length, 4,633 bytes, which I think if you look at these byte totals here and add them together, you should see that those sync up. And then we also have this cross-site description protection header before we finally have our new line indicating the end of the optional headers and that the following should be our HTTP message body. If I go down here to line-based text data, sure enough, that is going to be our actual HTTP response message body. So it's actually the page that's being downloaded here. And you see there's quite a bit of that information available. Now, this is not the best way for examining the contents of what was transferred because you have to, obviously if you're scrolling down here, this packet bytes window is not a really good way to do that, even if it is reassembled. The best way to do that is going to be to utilize the technique we talked about earlier about following HTTP streams. I can right-click any of the packets in this conversation, go to follow, and tell it HTTP stream. Now, if you remember back to our earlier conversation, why wouldn't I click TCP stream if it's highlighted and unavailable? And the answer is that HTTP stream is actually going to automatically go ahead and deflate gzip encoded data and show that in clear text. TCP stream will not necessarily do that, and you might just get a bunch of junk you can't read. But if I click on HTTP stream, I will actually be able to see the decoded data, and in this case, we see all of that here. So we see doc type HTML indicating this is the start of an HTML document, and then we see all of the different clear text HTML data that goes along with that. It may not be formatted in the most easily readable way, but it's a lot better, and it's probably the best you're going to get, at least from Wireshark. Of course, from here, you can also take this, export it out as well. We can tell it we only want the response information and save that as a file, and then even open that up in a browser. You want to be careful doing that, especially if you're examining something where you're concerned there might be a security risk, because when you open it in your browser, you might generate additional communication that you're not really going to want. But this is a quick way to go ahead and view that completed HTTP stream as a part of this very simple HTTP GET request. The next type of normal stimulus and response is going to be quite similar, and it's an HTTP post. Whereas a GET actually retrieves or requests data from a server, a post actually sends data to it. So you think of a post in terms of probably the most often thing you'll encounter is either logging into a website, so you're posting authentication data, or filling out some type of form. Maybe you're filling out a survey, something like that, putting data into the system and sending it to a server so it can process it and return something based upon that data. That's what you're doing with a post. Now, for the most part, a post follows a similar structure as a GET, right? It's just a different HTTP request method. So in this case, we'll do a post, and let's say we're doing it to wp-comments.php, which means we're probably leaving a comment on a WordPress blog entry. And then we would get a response back, again, an HTTP 200 OK, ideally, although there may be some other things that make a little bit more sense in the case of a post. Now, the thing to keep in mind with a post is whereas a GET generally doesn't have anything in the message body of the request, the post generally will, right? Because we're sending data to the server, so there will almost always be some type of information in that post and that initial request that the server will then respond with. Now, a lot of the times the server may just respond with a 200 OK, but many times the server may respond with some type of redirection, right? If you think about posting a comment to a blog post, right? You enter that comment and post it, and then what's going to happen is the blog is going to refresh that page with your comment added. Or maybe you're purchasing something, or better yet, let's say you're logging into a system. You go to a website that's protected. It's presenting you with a place to input your credentials. You input those credentials and send them, and then you get redirected to the page you were trying to get to, but in this case, you're actually authenticated So redirection is a specific sequence or a specific process within the context of HTTP. So I want to talk about that next, and then I'll show you an example that combines the concept of an HTTP post and a redirection. Now, there are two types of redirects within HTTP that I really want to talk about here, and we'll go through both of those really quickly, and then I'll show you an example. They're not too complicated or too much different than some of the things you've seen already. Now, in this case, we have a system A and system B, just like we've had a web client, a web server, and the web client sends a GET request to the server for /, so the root directory or the document root or web root of the server. Now, in this case, the server actually wants to redirect that request. It says it doesn't want you to get just / because actually, if you're requesting /, it wants you to go to index.html. That's the document that it most wants to send you to. That's the home page, so to speak. So to do that, a specific sequence has to happen, and there are a couple ways. There's a permanent way and a temporary way, and I'll show you both of them. First, we'll talk about the permanent way, and that's going to be done via the 301 status code, which means moved permanently. So it will respond, the web server will respond with that 301 code and also a specific entry in its location field. Remember, when we talked about response headers, we talked about the location field and how it was used in relation to redirections, and this is where that kind of manifests. So the web client, in that case, the browser, will receive that 301 code and automatically generate a new request for whatever is in that location field. So you see now it's going to make a request for index.html, which is what was included in the location field of the moved permanently response. So moved permanently basically means that it's telling the client, hey, anytime you are going to request /, go ahead and request /index.html. That's a permanent thing. Now that nuance isn't really captured too well in a browser. That's really more for crawlers that crawl websites for search engines, things like that, and how they cache specific things. That's where that really manifests, and that's really the difference, practically speaking, for most permanent versus temporary redirects. So you don't have to worry about that too much. All that matters in a specific situation you're looking at is that now once system A receives that location field in the 301 response, it will then request a new request the page that is included or listed as the location there, and people will use those kind of interchangeably, the 301 response or the one we're about to look at next, the 302 response. Now let's look at that 302 response, and it's going to be a very similar process. In this case, the client is going to, let's say in this case, it's going to do a post to wp-comments.php. It's posting a comment, and in this case, once the comment is posted, once the server receives that data, it wants to redirect the user back to the individual post that they're looking at, and that's a page called post.php. So it's going to respond with a 302 found, which is considered to be a temporary redirect, and provide the location field, in this case, chrissanders.org/post.php. At which point, System A will go ahead and request post.php. It'll make a GET request to post.php, since that's what it's being redirected to. So we're moving from a post request method to a GET request method because that 302 response was interjected there. So again, there's a subtle difference between temporary and permanent redirections, but the process is very similar. It's a difference between a 301 and 302 response code, but they'll both generally cause a browser to be redirected to a new page. The real nuance is in how search engines will index those moves and what they'll index in the search engine when you go searching out particular websites. But nonetheless, these are the two types of redirects you'll encounter most often. So let's go ahead and look at an example of that combined with an HTTP post in a packet capture. I've opened up http post.pcapng now to show you a couple of the concepts we just talked about, both the HTTP post and a redirection that's all part of normal stimulus and response. Now in this capture, we have 172.16.16.128, which is our web client, and our web server, which is 69.163.176.56. And in this case, we're communicating with a WordPress blog, so it's similar to the example I just talked through. Now, we're talking TCP communication still, so we have our first three packets are send, SYNAC, ACK to set up that TCP communication. Our first HTTP packet here is actually a post, so we're not starting with a GET request, we're starting with a post request, and it's a post to wp-comments-post.php, so we're posting a comment to a blog. And if we go down here and look at the HTTP transaction, we can see that is my blog, chrissanders.org. So we see our start line is obviously what we just said, the WP comments post.php. The host is chrissanders.org. We see the user agent in this case, once again, is Firefox running on Windows. We have some accept headers, so accept language, accept encoding, accept character set, the same things we've been looking at. Of course, in this case, we actually have a refer. I don't believe we saw that on the last example. We see that it was referred by chrissanders.org, $P equals 310, so that's a specific post on my blog. Not sure what that one was right offhand or if it still exists, but it certainly did, certainly did at one point. Now, of interest here is notice we have content type, and content type is something we didn't have on our GET request because we didn't actually have any content, right? There was no message body associated with that. But since we're posting data or sending data to the server, we do have a message body here, and we see that following our blank line. So here's our blank line here, and if we go down, we have HTTP form, URL encoded, which is actually just a comment to a blog, and you can actually see to that effect down here in the packet bytes. You see author equals Chris Sanders, email equals chris@chrissanders.org, and here's our URL, and this is a post test down here in the packet bytes. So you see that information is available, and that's what's being sent to the server. So once again, we have an acknowledgement from the server that the data was received, TCP communication here, so it's session aware. And then we see the server response. Now in this case, we see the response immediately because there's no data sent immediately. The thing we have immediately sent is this response code of 302 found. So we don't have a 200 OK with data being sent. We have 302 found. Now, that means, in this case, it can mean the server processed the data, right? It doesn't mean that the data wasn't processed and that things aren't OK. The data was processed, but in this case, we're just responding with a redirection to redirect the web client to a new location. So if I expand the header here, we see that response code in the first line and the start line, so 302 found. And the important thing here is the location field. So look, location, chrissanders.org, page 310, and it looks like it's going to redirect to that comment. So when you go to the blog, you actually type in your comment, hit post, and it accepts the post, accepts your comment, and then refreshes the page with your comment now visible on it with focus on there, right? So that's what's happening here with this anchor link for comment 103.002. So it's redirecting the user's browser to that, along with all the other things we've already talked through in terms of the HTTP response. The real thing we want to focus on here is just this this location field. So since we have a redirect, the thing we should expect to see after the redirect is a new GET request. And sure enough, we see that here in packet 7 from the client. We immediately see a GET request for the URL that was specified in the location. So we see the request URI is page 310, see page 1 in this case. And so we're all set. So at that point, the new request is made. What follows that are a bunch of TCP packets. This is actual data from the page being downloaded. And then down here in packet 18, we see our reassembled HTTP response, which includes the status code of HTTP 200, which means things are okay. And then finally, our connection is torn down through the normal TCP teardown process. So pretty cool. That combines two things we talked about, both an HTTP post where you actually have a message body on the request and a redirection using a 302 found. Both perfectly common normal things you'll see every day when examining HTTP-based communication, normal stimulus and response.